Here we're going to talk about the root test. And the root test is useful if you have a series that's defined by a rule to some kind of power or some type of root, right? And remember that there's a relationship between exponents and square roots and cube roots and those kinds of things. But if we have some series from k to infinity, and the rule is a sub k, as long as you have positive terms in your series, then the root test applies. And what we'll be looking at is the limit as n approaches infinity of the nth root of our rule, or if you prefer, we'll be looking at the limit as n goes to infinity of our rule to the 1 over n power. And notice that's just the relationship between some type of root and its exponent. Let's assume it has a limit. There's three possibilities. The limit, when you apply this test, is found to be less than 1, which means that the series converges. Or the limit could be found to be greater than 1, or the limit equals infinity. This means the series is divergent. And the one thing you don't want is you don't want the limit to equal 1, because then the test is no good. You have to do something else. We just have an inconclusive situation. Right. So, by way of example, let's consider this series. The sum of the series from k equals 1 to infinity of 5 over k to the k power. Now this is is something you would want to consider the root test for, because we have some expression to the k power. So what we'd like to consider then, using the root test, is what is the limit as n goes to infinity of the nth root of the expression 5 over n to the n. And the nth root of something to the n power is just the expression itself. So we're really looking at the limit as n goes to infinity of 5 over n. And we know that something like this, because it's p series, goes to 0. Take that back, it's not p series, but 5 divided by really big numbers goes to 0. So since the limit is less than 1, we know that this whole series converges. So the limit of the nth term is 0. 0 is less than 1, so this series happens to converge. Let's consider another problem, just as an example. Sum of the series from k equals 1 to infinity. And we'll look at, k times e over k plus 1 all to the k power. Now because this whole thing is being raised to the k power, it's a good candidate for the root test. So we'll want to consider the limit as n goes to infinity of the nth root of our expression. So n times e to the n plus 1 all to the nth power. And that's going to be the limit as n goes to infinity of n times e all over n plus 1. Since this numerator is first degree, n to the first, the denominator is n to the first, the limit as n goes to infinity is the ratio of the coefficients. In this case it will be e over 1, so the limit is e. And because e is greater than 1, we know that our series diverges. Right, so the issue with the root test is if you have a series that's being expressed to some power, like the k power, the n power, whatever, the root test is a good candidate to use because it simplifies your expression quickly.